Hi there and welcome to this session with Wiskunde. Now in this session we're going to be doing calculations with mixed fractions. So if you don't know what a mixed fraction is, I would suggest you go watch the video on different types of fractions and how to convert them first. Alright, so in this video we're going to be doing calculations, and if you need some assistance in doing that, then please continue watching. Okay, so before we start, it's important that you know what a mixed fraction consists of, as I said. Okay, so if I look at the sum on the board now, I have a sum where I'm calculating two mixed fractions, and what I'm doing is I'm adding these two. Now, it's important for you to first understand that I could actually write these two separately. I can actually write it as 3 plus a sixth plus 2 plus 5 sixes. And it's important that you know that, because when I look at it now, all I can do is I can now group them according to the association property. I can now group and add the whole numbers together, and I can add the fractions together. And that is exactly how you will treat doing calculations with mixed fractions. You add the wholes together and add the fractions together. So now I will add the 3 and the 2 because they are two whole numbers. And then I'll add the fractions. Now, to make it even easier for yourself, you can regroup them. You can rewrite it in the certain way that you want. So you can write it as 3 plus 2 plus 1/6 plus 5 sixes. Okay? But I'm just going to go ahead and add them immediately. So now, after this step, I'm going to say 3 plus 2 is 5. And then I have 1/6 plus 5 6 is 6 sixes. And we know that 6 divided by 6 is actually 1, which makes that 5 plus 1, which just becomes a 6. Easy, right? Now, if it was just a fraction, you could have just written it as 5 and 6 sixes, but we are able to simplify the 6 sixes as 1, and so we do that simplification and add them afterwards. Let's look at another example. Now, with the second example for mixed fractions, again, I have an addition sum. What I do is I break up my whole number and my proper fraction, and I will then add them according to association. So, my 7 and the 5/9 become a 7 plus 5/9. Plus, my 4 and 7/9 become 4 plus 7/9. And now by association, I can add my whole numbers and then add my proper fraction. So, I'll add the 7 plus the 4, which is 11, and then 5/9 plus 7/9 become 12/9. Now that is your final answer, and this could also be accepted, but we always want to simplify our answer. So if I look at this now, this is a whole number and an improper fraction, and we know that improper fraction means that it's actually more than a whole. And with mixed fractions, we always want a whole and a proper fraction, right? So if my whole was cut into 9 equal pieces, this means for it to be a whole, I need 9 pieces, but I have 12, so you have more than a whole. So I take away 9 from 12 and I'll be left with 3/9. So I will have 11 plus 9/9 plus 3/9. Now when I add these two at the end, I still have my 12/9. But remember, I'm trying to write it as a mixed fraction, so I should have a whole number and a proper fraction. Right, so I would have this 11 plus the 1, which is the 9/9, becomes a 12 and 3/9. So my final answer is a 12 and 3/9. What? I'm not done? Correct, I'm not done. Remember, you always simplify until you can't simplify anymore. And when I look at my fraction at the end, I can still simplify that fraction. I can divide both of them by 3. Divide by 3 on top and divide by 3 at the bottom. And that means my final answer would be 12 and 1/3. Alright, so that is how you simplify fractions right until the end, okay? But this is about as hectic as it can be for addition of mixed fractions. In the next set of examples, we're going to be doing examples where you do subtraction of mixed fractions. If you want to know how to do that, you should stay tuned. Alright, so now we're moving on to subtraction of mixed fractions. Now it's a little bit tricky, and because of the method we used in addition of mixed fractions, a lot of learners make the following mistake. So like we did with mixed fractions, we broke it up and we said this can become a 4 plus a third minus 1 plus 2/3. Right? Now what is problematic about this is, just like when we did subtraction, right, there were two things that were extremely important. The first thing about subtraction was that you always subtract the top minus the bottom, or you can look at it as the first number minus the second number, right? We're going to apply the same rule when subtracting mixed fractions. Then the other thing we looked at when subtracting, we broke up the number, right, to make sure that you subtract each number from the first number. So because of that, this makes this part over here problematic. Because if I'm subtracting 1 and 2/3, it means I'm actually taking this and I'm subtracting a 1 as well as subtracting 2/3. So to make sure you don't make this mistake, you put this in brackets, and then we'll be using the distributive property over here. So now this could be written as, this is still addition, and you subtract a 1 and you subtract the 2/3. Right, now with addition, the next step would have been, I'm going to subtract the whole numbers and subtract the fractions. But in some cases for subtraction, that is not going to be the case, because when you subtract, remember, you can't turn it around, okay? It's always the first one minus the second one. So if I look at my whole numbers now, I can say 4 minus 1, 3. That's perfect. If I look at the fractions, I can say 1/3 minus 2/3. No, because I can't say 1 minus 2. So there's where the problem comes in. So what we do now is we're going to borrow, right? So it's very similar to your subtraction method. So what I'm actually going to do now is I'm going to erase this method completely. And instead of using this, I'm going to show you how to use the top minus bottom method to help you with your borrowing. Right, so if I write it like this, remember when we did subtraction, the bottom number I changed and I made each number a different color. I made the subtraction a different color so you can clearly see that I have to subtract each part. Alright, so as we usually do, we start on the further right. Okay, so I would now have 1/3 minus 2/3, which I can't do because I can't say 1 minus 2. So what do I do here? I borrow, right? So if I borrow 1 from 4, I will have 3 left. And that one that I borrowed, I will carry over to the fraction side. Now, since it's a fraction, I need to write 1 as a fraction. My denominator is a 3, so I will write 1 as 3/3. This then changes this part on top to 4/3. So my new part that I have now is 4/3 in this column minus 2/3. Now I'm able to subtract the two of them. 4 minus 2 then becomes 2/3. And 3 minus 1 becomes 2. So my answer, my final answer is then 2 and 2/3. I will now do another example where I use the method where it's in a straight line. Please note, after this video, you can choose any method that suits you perfectly fine and that you are more comfortable with, okay? Now, if I wanted to continue with this method, what I had to do was I would have said 4 minus 1 I can do, but 1/3 minus 2/3 I can't do, so I need to borrow from my 4. So what I do now is I can break this 4 up as 3 plus 1, it's still your 4, plus the third, and please note that this is still that first number, and I will subtract it from the second number. Right, so now I can rewrite this 1. Since the denominator is a 3, I can write this 1 as 3 over 3. And from here, I can now add up these two numbers. So this can become 3 and 4/3 then, minus 1 minus 2/3. Now I'm able to subtract the wholes and subtract the fractions. 3 minus 1 is equal to 2. And 4/3 minus 2/3 is 2/3. And that is then your final answer. Okay, that brings us to the end of this video where we're doing calculations with mixed fractions. Thank you so much for tuning in and watching right until the end. All the best with trying that exercise in your workbook.